All right, hello, sixth grade. Here's a quick review of your volcano notes. We started with an awesome picture of a volcano. We'll learn later on in the notes that this is sort of the crater or the caldera on top of the volcano. We had the question, are all volcanoes the same? The answer is certainly no. There's lots of different types of volcanoes in different types or in different places of the earth, and we're going to explore that in these notes. Just the first couple of things about the basics of volcanoes, all right? How do volcanoes form? Well, if there's an increase of temperature and pressure in the mantle, that molten magma will burst through. It'll burst through a vent in the crust, and it'll come out as lava. And the stuff that comes out the top, we'll see later, is ash and cinders, which is tephra. And there's a vent around the top, which is called the crater. Now, where volcanoes occur, they occur in three places on the Earth's surface, on the crust. Two of them are familiar. The third is a new one just for volcanoes, or special for volcanoes. The first is a divergent plate boundary, reminder, where two plates are coming apart, divergent. The other is convergent plate boundary, where two plates are coming together, convergent. And then there's the hot spots. And hot spots are these places in the mantle that are a little bit hotter than normal, and because they're so hot, this magma plume bursts through the crust, this hot spot, and create volcanoes there. So those are the three different types of where volcanoes can occur. Again, divergent, look at this. We have convection currents going on. The convection current splits apart the crust. And when it splits apart the crust, new magma can come up in the middle and new crust is formed. So you can have volcanoes where the crust is coming apart. The mid-ocean ridge is an example of that. And Iceland, the volcanoes of Iceland are where the plates are coming apart. So that's the first type. You can also have convergent plate boundaries, where one plate is converging on another, it's going underneath in a subduction zone, and when that magma goes down, it gets heated up, becomes sort of fizzy with all the gases that are stuck in the magma, and can explode out the top. So that's the second place. And then you have hot spots. Here it is, a hot spot in the mantle that can create these lines of islands, all right? And as we can see here, we have a hot spot, and as it grows, it creates an island, and then the whole plate itself shifts over, and it creates another island. Whoop. So the first island's moved over, it creates another island volcano, but then the plate moves on, another island formed. Bill Nye showed this with the volcanoes bursting through. So you get this line of volcanoes, a line of islands, the closest which has the active volcano, but it leaves this trail of old extinct volcanoes in its path. And as you can see here, as the plate has been moving in this sort of northwest direction, this hotspot, which is currently right here, created this volcano when the whole plate was over it. And it created this one a little bit later when this plate was over it. And now, today, is creating these on Hawaii. Kilauea is right there. There's a side vent right there. And there's a new underwater volcano growing right now as we speak that in theory could create a new Hawaiian volcano in a couple 100,000 years, which is pretty neat. In fact, this line of Hawaiian volcanoes goes way back all the way up here near the tip of the Aleutian Islands up here and near Russia. It's been going on ever since the plate's been going on. So this hotspot has been making islands for a long time. Think how far that plate's gone as this hotspot that is right here has been making those along, which is pretty cool. All right, so the parts of the volcano, pretty straightforward. You have your magma chamber underneath. It's like the belly of the volcano. The magma comes up a pipe. You can go up the main pipe or maybe side pipes. And wherever it makes to the surface, that's called a vent. You can have a side vent or the main vent up here. Up at the top, around the main vent at the top is a crater, or if it's very big and large, you can call it a caldera. And then what comes out of these vents is either lava that oozes out and cools, so you can have cooled lava there, or you can have ash and cinders exploding out of it, and that's known as tephra. So that can come sort of crashing, raining down on the volcano around it. So the volcano can grow by the accumulation of cooled lava or cooled ash and cinders. And a composite, as we'll see in a second, composite volcano has a combination of both. By the way, just a reminder from our old unit, this cooled exterior igneous rock is extrusive igneous rock. But what if the magma chamber itself had cooled down? That could happen and create intrusive igneous rocks like granite. See, it's all coming together. That's pretty cool. So the three types of volcano. The shield volcano. This is not an explosive volcano. It's an oozing kind of volcano. It oozes out lava and grows slowly in these huge, wide, shield-shaped volcanoes. Hawaii, a great example. Then you have a cinder cone. It is explosive, but it's not very big. It's explosive and shoots out ash and cinders, which again we call tephra, and it builds into a sort of a nice cone shape. Wizard's Island, which actually you'll see a picture of a little bit later on, is an example of that. Then you have a composite, or sometimes called a stratovolcano. And sometimes lava comes out of it, oozes out slowly, but sometimes it blasts out tephra, and these can grow very big. Mount St. Helens is a great example of that. Krakatoa is an example of that. Some of the big ones, Pele is an example of that. The big, most dangerous Vesuvius types of volcanoes are composite volcanoes. They're big and powerful and can be explosive. Again, shield cone, oozing out. It's coming pretty slowly. Jane, the geologist, she's good to go. There's just nice cooled igneous rocks here. She's pretty safe on a nice big shield cone. Cinder cone. Okay, yeah, it's explosive. It's shooting out some ash and cinders, maybe some volcanic bombs. She's got her hard head on. She's taking it pretty safe. But you know what? It's small. It's not going to overwhelm her. She's okay. She's not going to get too close. But she can get away if she needs to. All right, she can walk to it. She can walk away. It's not like the cinder cone is going to just blast everywhere and knock her down. I mean, how could that happen? I mean, what could a volcano could do that? Oh, the composite volcano. Boom! It erupts. Not just lava, but it can erupt cinders and ash and pyroclastic flows. Pyroclastic flows being this a mixture of poisonous gases, and it's intensely hot and has little bits of stone and dust and gas and heat, and it moves at like 100 miles an hour and just comes right down the mountain. She's in trouble. There she goes. So a composite volcano can be the big dangerous ones, as we've seen there. A review again: cinder cone, shield, composite, and a better way to look at it here. Here we are breaking it down. The shape of each one. So a cinder cone is cone shaped. It's explosive, and tephra comes out of it. A shield is shield shaped. It's gentle, erupts gentle, and lava comes out of it. And then a composite volcano is like a big, big mountain. It can sometimes be explosive or gentle, and it can both have both tephra and lava and pyroclastic flows coming out of it as well. Just a reminder, tephra is a mixture of ash and cinders, and lava is liquefied rock, right? It's magma that makes it to the surface there. We didn't go these in class, but we can just say it right here. Mauna Kea, this is a shield volcano. Actually, this picture, this is a little cinder cone on top of it. Look at the back here. This whole thing in the back is a shield volcano in the back. Mount St. Helens, composite. Wizard's Island, here's a little cinder cone right here. It's a little cinder cone. This cinder cone volcano is actually inside a huge caldera, an ancient caldera. This whole lake, it's called Crater Lake, is actually made of a caldera of a much, much bigger volcano. Oh, and there's Mount Fuji. It's also, it's a stratocone or a composite volcano as well. All right, I think that's it for the notes there. You can use these as your review for a little quiz. You can also use these notes as you work on your video project. I'm very excited to see those as well. Okay, that's it. I will see you later. Bye.